In this video, I'm going to compare and contrast commercial duct design versus manual D, or residential duct design. Very similar steps, just a slightly different order between the two. In both cases, let's start with a diffuser layout, and we'll go through the commercial workflow first. So the first step with commercial duct design is to lay out your duct, and you might end up with something like this. The next step is going to be you set your sizing parameters, and this is where the order already starts to differ from residential duct design. So in commercial, the engineer sets their duct sizing parameters first. It's performance driven. So they want this duct to operate at, say, 0.08 inches of static pressure per 100 feet. And so that parameter is already set, and they're going to next size their duct. So they have the sizing parameters, they have all the airflows. They're going to sum up those airflows and go segment by segment and size the ductwork based on the sizing parameters they set ahead of time. It might look something like this. Step 4 is calculate ESP, your total external static pressure, which involves finding the critical path and doing a pressure loss calculation for that path. That's going to be the total ESP required for your duct system. So the engineer may determine the critical path looks something like this, and they do a ESP calc, and it comes out to, say, 0.5 inches ESP. All right, so now the final step, now that they have the ESP and they already have the total airflow, is they're going to select their equipment. And they select the equipment to meet the performance required by this duct design. It has to meet the total external static required for this system based on the sizing that was already done and the sizing parameters that were set ahead of time. Now, let's compare this to the residential workflow. The first step is the same. You will lay out your duct. And a lot of times with residential, it's a bit simpler. You are allowed to have longer runs of flex. So you typically see one long main, and then you'll have more branches tapping directly off of flex duct going straight back to this main branch. This is fairly common, and it makes constructability a lot easier, especially in homes. And this is where the workflows start to differ. Instead of sizing your duct now, in residential, a lot of times you select the equipment first, and this is going to drive your duct sizing based on how much static this equipment is able to provide. So let's say the equipment selected can provide 0.75 inches of external static. This is now going to be the driving factor in how this duct gets sized. Step 3 now is to calculate the critical path equivalent length of ductwork. The duct has not been sized yet, but the engineer is going to determine the equivalent length of this critical path. They're going to incorporate different fitting losses, and then once they have that equivalent length, step 4 is to determine the sizing parameters. It's sort of the inverse of how commercial does it. The residential designer is going to determine what friction loss to size their duct to, such that the available 0.75 inches of static will provide airflow through the critical path. You're using the available static from your equipment and this equivalent length from the critical path to determine, okay, maybe it's 0.1 inches of static loss per 100 feet that I can size this duct to. And now you have that sizing parameter. So the final step is to size your duct. You're now using the friction loss parameter you calculated to ensure the duct sizes that you set here can accommodate this 0.75 inches of available static.